tomorrow from 2:30 to 4:30. You're welcome to bring in, a page of notes with you, standard 8.5 by 11 sheet of paper. You write anything on there that you'd like to and bring that in. Don't need a calculator. Again, I'll go ahead and reduce matrices for you. I may put a question on there to see if you can reduce one by hand, like one of those ones that has an H in it that says something that makes you reduce it by hand. But if you do need to reduce something to solve a system or, check for linear dependence, whatever, basis for a null space, whatever, any of those kind of questions, I will just reduce the matrix for you.
What about inverse of a matrix? If our calculator can do that, are you going to put inverses on, or do you just need the work for them?
So I'll do the same thing I did on the last test, which is I reduced the matrix for you and asked you to interpret the results. The format will also be the same in that, I'll send out like individual smaller group invitations for Google Meet. I'll email the test out, right at 2:30, or I'll post it to Blackboard, I should say. And then I'll ask that you follow the page breaks just like last time and scan them and send it back to me just like last time. I'll provide my phone number like last time, all that kind of stuff. It'll be the exact same kind of format, just at a different time. I think it actually is going to be a similar length too, maybe even a little bit shorter. I learned in the last test that, given the circumstances and depending on people's setup, sometimes it takes people longer to do a test in this setting. So I'm trying to maybe reduce the number of questions on there / make it so that it'll take you less time. I think having notes in front of you should automatically make it take less time, right? I mean, there's going to be less thinking and more just working through the test. That's one of the reasons why I want to give you the notes. Please keep in mind too that just the way that the cards fell, our last 2 web work assignments are actually due Wednesday at midnight. So that was stuff on eigenvalues and vectors. It was chapter 5. And that, I put that on the final exam review, but since technically the web work is due after the exam, I'm not going to put any eigen stuff on the final, right? I'm going to sort of test your knowledge of that material just through the homework. So again, I apologize for that, but that's just the way things turned out. And, I'm going to drop your lowest couple of homework grades anyway. So if you chose not to do those, they would just probably get dropped anyway. Let me see how many.
I have a question about like the homework. So I've been doing all of the homework assignments on web work, but like recently I noticed there was like Blackboard assignments for each of the homework things. If for some reason we didn't click on those during the course of the semester, but still did all the homework on web work, do we get credit for the homework?
Yeah, those ones that are on Blackboard, which I actually am going to delete right now, while we're talking, those are just to put them in the schedule. And so those don't actually get grades. What's going to get a grade is after Wednesday, after the last homework assignment's due, I'm going to download the grades from web work and I'll enter an actual web work grade on Blackboard. So yeah, so you don't need to do anything on Blackboard to get homework. You should do all your work on web work and I will transfer those grades over.
Yeah, there's also something similar for the videos.
Yeah, right. I just tried to create these placeholders because what it did when you did that is it would populate it in the calendar. And so I was trying to make these things show up in the calendar by just having them, like putting a placeholder for them. So yeah, you don't actually need to do anything. I will transfer those things over myself. It's a real, it's a real pain in the butt, which is why I don't do it very often. Like it takes me a good half hour to like make that happen. So that's why I usually wait to do that. Other sort of thoughts or general questions like that before, the purpose of today is to do some review. I really only got, I think, one or two questions. Someone had asked about some of the invertible matrix theorem type material, if we could look at a couple of those questions from 2.3. But I think other than that, I don't think I received any emails or questions. So I'm not just trying to remember quickly here. Looking through my email. I had a bunch of questions for my pre-calc class earlier, but I don't think anyone from this class really asked anything. So if I'm mistaken, let me know, or if you wanted to look through the review right now and ask me some questions, that'd be fine. But this is your time. Yeah, Finn?
We did.
Can we just generally go over any type of question that will absolutely be on the exam?
That is one of the worst questions I think I've ever had.
Okay, that's
I'm sorry. What do you mean by that? You want me to just send you the exam right now, or?
No, just go over problems that, hint, you better be studying for, etc. Just any with that type of thing.
I think
don't
the
know how to put it to
hint, you
words.
better be studying for those problems are kind of like at his discretion to.
Yeah, that's a good
What's on
question. Here, I don't know if there's anything. I mean, you should be able
Basically,
to.
going over the final review that you posted, just the one that's going over the topics. I can't remember what the file's called.
Let me see.
I'm pretty sure it's just final exam topics.
Yeah, it's final exam topics.pdf.
Yeah, that's what I'm meaning.
So, I mean, obviously being able to solve a system comes into play a lot, like knowing when a matrix is consistent or inconsistent. That's something that comes up probably in more than one question. I would be thinking about things that were not on the last test, right? So on the last test, it was like chapter 1 through 2.2 or whatever, right? So when I posted the final exam study guide, it's like 2.3 on. And so I'm going to try to make sure that those things are being on there more so than things that were already on the first test. Now, having said that, all of chapter 1 was about like row reducing and knowing when things have a solution and stuff. And that stuff obviously comes into play in later sections. But I think if you just take what I'm saying and think like, okay, there weren't a single question about determinants on the last test, for example, I'm probably going to ask you to do a determinant on this one. Proving something's a subspace. I didn't ask you that on test 2. So I'm probably going to ask you like, is this a subspace or not? Like that kind of question. I think you should, I wanted to see that you can do everything basically, right? And I've already tested you on some of the things, but not the second half. And so I'm going to focus on the second half, I think is what I'd say. Don't ignore the first half, but that's what I'd sort of say about giving you hints about what to study.
Last night, me and a few other people sort of went over some WebWork questions, and we decided to compile a list of WebWork questions that might be helpful if we were to sort of go over again. So the list that I have here is not like too many, but it's so I don't like I wouldn't want to spend like a lot of time on this because I realize other people might have questions, but WebWork 4.1 number 1. I don't actually have notes as like what these were. I just sort of wrote down the actual question on WebWork. So you think we could go over?
Fill that up. It's a move.
Yeah, sorry, I didn't send. I'm
sorry.
What are you
doing, man? I literally said, "Can you send me any homework questions ahead of time?" And you had a list of them that you're just like springing on me right now. What is wrong with you? Why didn't you send those to me, man? Okay. Literally, why I sent the email. So frustrating. All right, I've got 4.1 right here. I'm gonna have to write it down by hand, of course, because you chose not to send it to me ahead of time. You were like halfway there. You even went through and wrote a list down. You're just like hiding them. 4.1 number 1. My goodness, man, this is such a long problem. Why didn't you send this to me?
Okay, so maybe let's okay, perhaps let's not like do okay.
You even know it's like a long list. It blows my mind sometimes. You're a very smart person, but you just did this repeatedly the entire time. So this question says, what is a basis for this, I think? Let me open it back up again. Oh, is it a vector space? So it says W looks like vectors like this. B and D are real numbers. Is this a vector space? So, and then there's a bunch of options. I'm not gonna write out the options. It says like it's not a vector space because it's missing the 0 element. It's not a vector space because it doesn't have additive closure. In other words, it's saying go through the subspace things. So I know it says vector space, but this is clearly a subset of R4, right? There's 4 elements in here. And so we just need to check the subspace conditions.
It's just that this is sort of the only one on that web work where I sort of fail to see like how we would like have tested it. I know I completed all these web work, so I know that like so I must have known the way to do this at like some point, but
Right. So what are the subspace things? There's 3 subspace.
The subspace, it's if it contains the 0 vector, if it's closed under addition, and if it's closed under multiplication.
Right. So you like add 2 plus things. You add 2 things together, and you see if it's in the set, and then you multiply by a constant, and you see if it's in the set. Right. So 0 is a yes. I'm just going to sort of talk through this one. 0 is a yes because you can plug B and D can be any numbers, right? And so you can just let B equal D equal 0, and you'd get the 0 vector. C, so let's let U equal something. Let's just let that equal U, right? If you multiplied this vector by C, right? If you did CU, it would look the exact same because it would just be like all this thing right here, just with a C attached to all those different terms. Right? It would be like CB minus 2CD, like it would be in the correct form, right? You just add a C to all those things. So the U plus V is the one that fails though, because if you added 2 vectors together, U plus V, they both look like this, what's going to end up happening is the first term might be okay, the second might be okay, and the third might be okay, but in the 4th entry, you're going to get like 2D, I think is the problem there, instead of D. And this is not okay. And so because you need to have just a single D down there, not a 2 times something. I think that's what ends up being the issue with this one. Let me double check the answer here. Yeah, so the answer is B. V is not a vector space because it does not have additive closure, right? And so this one fails, which is why this one in particular fails. This one's kind of a weird. I feel like the way that this one's set up is kind of funky.
Yeah, this is definitely different than the rest of them on the web work.
I'd be more inclined to ask ones more like the other ones in this one, where I say like I give you a quadrant or something like that and ask if that's a vector space, or a line through the origin or something like that. So Fidget, I really don't mean to like jump down your throat and try to discourage you from asking more questions. I want to hear more questions. It's just like
I'm sorry. I should have sent. I
know. You don't do that. But anyway, that's fine. What are the other ones you wanted to look at?
Let me I have the list here, but I also now want to look at the web work 2, just so I can sort of ask the question without maybe you having to write as much here.
Sure. So maybe you can go ahead and look at that, and Sydney had asked a couple questions about 2.3. And so I'm going to maybe look at one of those. So I think she just wants to look at section 2.3 is it's the IMT homework set. And I know you just said, like, could we do some of those examples? I was assuming we could just look at some of the homework problems. I didn't actually print any out because I was just going to ask you that here. I think that's okay. And so, like, question number 1, for example, says, if a square matrix has 2 identical columns, the matrix is invertible. You know, so I really think that one of the biggest advantages compared to, yeah, I'm gonna go ahead and just mute that. Yeah, thank you for doing that. Great. Anyway, one of the biggest advantages of being able to write down notes on this thing, obviously it's a huge advantage in a lot of ways, but one of the biggest one is because you can have the invertible matrix theorem written down. Where usually people have to memorize it and you have to, which is, in my opinion, one of the harder things that people need to do. So I'm trying to find my copy of it. I should have just printed one out. Shoot. Thought I had a hard copy right here. Let me just pull it out of 2.3. So basically what's gonna happen in a lot of these things is you're gonna be told, you know, if you have two identical columns, that says something about the invertible matrix theorem, and then we'll know whether or not it's invertible, right? And so here is the one from 2.3. Now, and actually, did I post the full thing there? Let me check Blackboard real quick. Usually I try to post the entire invertible matrix theorem before the final. I can't remember if I did that. I apologize if I didn't. It's under test topics and solutions. The full IMT is there. And so not only does the full IMT go through L, but it also goes all the way to T. Let me just maybe share my screen right now. I really want to make sure everyone's aware of that because I think that's a good thing to have on your sheet. Then you don't have to memorize it. So I'm sharing my screen. You would want to, if you had my thing pinned, you would want to unpin so that you can see Blackboard. I'm showing Blackboard. Again, this is in test topics and solutions. The full invertible matrix theorem is right here. And when you click that, you'll see the thing that I had on my screen a second ago, which goes through L. So this is from 2.3. But then we started tacking things on from other sections too, right? So this second part of it was like from chapters 3 and 4. And then the last part was from chapter 5, which we don't really need for the final. But this is a nice thing to have, basically, these things on the final. So not just through L, but through R. You might want these ones as well, right? Okay, so I'm going to stop sharing, go back to this page again. So we're being told in this problem that 2 of the columns are identical. Well, if 2 of the columns are identical, that means that they're not linearly independent, right? That means they're linearly dependent. And so where is that one here? Right here. E says the columns of a matrix A form a linearly independent set. So that's false. If 2 are identical, then E is false. And so if E is false, that means that A is also false. And so that's how we would do that problem, right? So this implies the columns are linearly dependent. And that means that the matrix is not invertible. And so that's the kind of question. I do ask these questions in true-false form oftentimes in the final, where it's very similar to this, where you kind of like take the piece of information you're given, link it to the IMT in some way, and then figure out the implication of something else in the IMT from that. So Sydney, is that the kind of thing you were hoping to look at? I'm happy to do another one, but is that helpful? I don't know if that's what you wanted. Sure, yeah. So number 2 set in the same homework set says we have a linear transformation from Rn to Rn. So it's a square matrix defined by T of x equals AX. And it says if there are 2 vectors such that T of U equals T of V, then columns of A are not linearly independent. This one's kind of a mouthful. Wow. So it's being told we have a linear transformation that's represented by a matrix, right? We know that all linear transformations have a matrix representation. And we're being told that two different vectors get sent to the same place, right? And so if we look at the IMT, that means that the linear transformation is not one-to-one. So where does it say that? Right here. Right? The linear transformation being one-to-one would mean that every vector gets sent to a unique place. And so F is false. And so if F is false, then the columns would not be linearly independent, right? So if F is false, then E is also false. And so this is actually the way that this is phrased would be true. So T of U equal T of V means T is not one-to-one. And so that means that A has linearly dependent columns. Other IMT type questions, either questions about these two or other ones that you've been looking at since you've been studying? All right, let me shift back to Finton then. Finton, do you have something else you want to throw out there?
Yeah, after looking at a few of them, I figured that I can sort of whittle it down. There's one on 4.6 that we were a bit confused on. It says suppose that A is an n by 4.6 problem 5.
Okay.
It just says suppose that A is an n by m matrix of rank 3. So that means there are 3 vectors in the basis, and yeah. So that means, rank 3, and rank plus nullity equals the number of columns. And it says the nullity of A is 4. The column space of A is a subspace of R9. Find the dimensions of A. So obviously it has 7 columns because 3 plus 4 is 7. And it's in R9. However, it does say it's a subspace of R9. So the correct answer on WebWork was it has 9 rows and 7 columns, which seems like it makes sense, but if it's a subspace, couldn't it also be, say, 8, 7? Or is there a detail about subspaces that I'm missing there?
Let's see here. I was mostly half listening to you as I wrote this down. So you are on the right track. Let me just start thinking this one through, and then you can stop me when we get there. So like you said, we know that rank plus the nullity equals n, the number of columns. And so we're being told the rank is 5, and the nullity is 3, and so the number of columns is 8, right? And so what we have is 5 plus 3 equals the number of columns. And so we got 8 columns. Does that seem okay?
Well, my example says different, but yeah, it makes sense.
Yeah, I'm sorry. I didn't click on your specific one. I just opened up
it's
some random one. But you got me, right? So we had 5 plus 3, and so we got 8 here. And so the question is, how many rows are there? Let's see here. Oh, and so then that's where the column space comes in, right? So we use these two things to get the first answer. And then if it says the column space is a subspace of R8, that means that the columns are 8 by 1, right? And so that means there's 8 rows then. If the columns are 8 by 1, then there's 8 rows. And so this one, the answer to this one, by the way, the question was, what's the dimension of A? And so the answer of this one is A is an 8x8 matrix. So sorry that one's different than yours, but can you relate it to the one that you were talking about? What numbers did you have? Did you have rank?
The numbers themselves don't like matter so much. What matters is sort of the I just had rank 3, nullity 4, and R9, but all I was confused on is if something is R a less, if it was R say 7, wouldn't that still be a subspace of R8 because it's smaller? Or
no? But yeah, I see what you're saying now. So if you want to be in R8, that means you have to have 8x1 size things, and so R7 is not a subspace of R8 because these have 7x1s and these are 8x1s. So like, you can kind of think about the XY plane. Like sometimes people think this, for example, like if this is x2, x1, and this is x1, x2, x3, right? So this is R2, this is R3. Sometimes people will say, or people think, I'm sorry, I wrote this kind of too close. This is supposed to be separate here. Sometimes people think, oh, well, the x1, x2 plane is a subset of R3 because the x1, x2 plane is like the floor right here, right? Like here's the x1, x2 plane within R3. But every point in this space is of the form x1, x2, and everything in this space has 3 entries, even the ones that are in the x1, x2 plane. Right, they just have the third entry being 0. Like this point right here might be the point 1, 1, 0. And so it has 3 entries. It's just that one of them is 0. So you can't really say that R2 is a subset of R3 or subspace of R3 because these things have 2 entries and these things have 3. Do you see what I'm saying?
Okay. So just based on the fact that they have a different number of elements sort of rules out the idea that it could be a subspace.
Yeah, right. Yes.
Even if like we added another 0 onto there, and because I know that if it was like 1, 1, 0, that would be a subspace of R3 because that's closed under addition, multiplication.
Sure. Yeah. The x1, x2 plane in R3 is a subspace of R3, but the x1, x2 plane in R2 is not a subspace of R3.
So having the same number of elements is a requirement.
Yes.
Okay. Thank you.
It's kind of a subtle thing, and I totally get the question, but it has to do with the number. It's the dimension, right? It's kind of like saying like things in this dimension only have 2 elements, right? They're pieces of paper. Where things in this have 3, even though some of them are flat, like this one, for example. But it still has a third dimension. Just some of them are 0.
I think I understand now. Thank you.
It's a very subtle thing, and I don't want anyone to get confused and be like, whoa, I don't know what's going on here. Not a huge deal, not something I'm going to ask. That was a kind of a subtle clarificational thing. What else?
I guess the last one that could really be helpful is 4.3, question number 4. It's just the one. It's just the one that It's the one. I don't know if you remember this one that says hint: consider the system of one homogeneous equation to solve the system. It's the find a basis of the subspace of R3 defined by the equation.
Yep.
In my case, it's 5x1 minus 5x2 plus 4x3 equals 0. I'm not actually sure why we have this. Why we wrote this one down. Now that I think about it, but wouldn't you just do what it says and make it a system of equations with an sort of have 5, -5, 4 in an augmented matrix with 0, and then solve for. Well, I guess after you do REF, you can.
Which would just be dividing by 5, right? So if you just said REF, you just divide everything by 5 and you'd get this. And so when you solve that, you would get x1 equals x2 minus 4/5 x3. And then you just write that as a parametric solution. So it would be, let's see here, 0, 1, 0, x2 plus 0, 0 minus 4/5 x3. Right. Wait, now I'm confused.
I think I know that in my answer it said that the 4/5 was on the top of the second vector. So
I mean, one thing is that x2 and x3. I'm sorry, I messed up the way that you actually do this one. Yeah, sorry. I need to review how to solve systems. That's not how you do it. Right, so you do that. That's the x1 value. This is the x2 value because it's free. And this is the x3 value because it's 3. And then we write down the solution. I'm sorry about that. So it'd be like this. It'd be like x2 minus 4/5 x3, x2, x3, which equals 1, 1, 0, x2 plus minus 4/5 0, 1, x3. And so then these two things are the basis elements, right? Because you're doing linear combinations of those two things.
yeah, okay, that seems to make sense. I think.
Sorry, you can go first if you'd like.
I'm fine. You can go.
Oh, okay. So just to go back to like the subtle like subspace thing you brought up before, your mic cut out when you were like explaining it for some reason on my end.
Mm-hmm.
But so just on the one of the quizzes, I noticed one of the questions was like, is R2 a subspace of R3? And it turns out that it is, but from what I heard in the explanation on the other part, you said that it wasn't a subspace of R3.
Which quiz are you talking about? Let me pull that
I
one.
think it's quiz 6.
Could have been an error on my part. Oh, maybe one of the ones I posted on Blackboard. Is that what you mean?
Yeah, it was one of the ones you posted on Blackboard.
One moment. Yeah, that's technically not the correct answer. R2 a subspace of R3. Yeah, no, that's definitely not right. Thank you for pointing that question out. When did I give that quiz? Maybe that was from early. Maybe that was from a couple years ago. That question's incorrect. Yeah, so quiz 6, question number 2. The correct way to word that one would be is basically what I had said before. Is the x1, x2 plane a subset of R3? And
would you solve it the same way, or would it be different?
You would solve it the same way, but each one of those things would have 3 entries. So it would be U would be of the form, see where it says U equals AB? It would be U equals AB 0.
Okay. Yeah, that makes a lot more sense.
And then everything else would follow correctly. Yeah, I'm sorry about that one.
Okay, thank you.
I think the last one that we had on the sheet was, if you're okay with
Yep, go ahead.
All right. It says it's 4.1 problem 12, and it says if A is an nxn matrix, so square matrix, and B does not equal 0 in Rn, then consider the set of solutions to Ax equals B. Select true or false for each statement. and it fails on all of them. It just sort of asks all of the axioms for if it's a subspace. Does it contain a zero vector? Is the set closed under addition? Is it closed under multiplication? Is it a subspace? And it fails under all of them.
Mm-hmm.
So, and it seems like the condition that it's testing for is if B is not equal to 0 in Rn, and the matrix is n by n. So I think that this one seems like it makes a lot of sense, but I would like to see how you would reason through this one, because
Sure.
we were a little bit confused as to what it was asking.
So it says we've got a square matrix. It says B is not 0. Specifically, that's an important thing here. It's saying that the B thing is not a 0 vector. And then we're thinking about solutions to this system. So in other words, we want the solutions are X. And so the first question, the first true false thing, and it is a true false. Let me just make sure that you're correct, that they all are false. Let me just look at the answers real quick. Yes, they're all false. So the first one says, is it true that the set contains 0? So if you do, in other words, if X is, right, if X is 0 and you do A times 0, you get 0, but we just said that B was not 0. Right, we're being told that B is not 0 as part of the problem, so that's why this one's a false. So you can't multiply A by 0 and get something that's not 0.
And I imagine that's sort of the crux of all of the other ones too, because obviously you could do 1, 0, negative 1, 0 and add them together to get the 0 vector. And with scalar multiplication, you could obviously multiply by 0.
So I think in the second one, so the second one says the set is closed under addition, question mark. And so let's say let's pick two vectors in the set. So let's say ax1 equals b, and let's say that a times x2 also equals b, right? So this is two separate things being sent to b. What happens if we add them together and then multiply by a? Right, this would be this. Each one of those things equals b separately, so we're going to get b plus b, which is 2b. And so when you add them together, you don't get b anymore. When you multiply by a, you get 2b. And so it's not closed. Right? This should be, this is not b. And so this is also false. Right? It would be true if we added them together and we still got b. With me so far?
I'm a little bit confused there. So we wouldn't just add two vectors together and see if they would.
We want to add two vectors that are in the set and see if it's still in the set. So here's two vectors that are in the set. These are two vectors that are in the set because they're solutions to ax equals b, right?
Yes.
And then I'm adding them together and seeing if they're still in the set. They'd be in the set if you multiplied by a and you get b.
Oh. Okay, so what you're saying is that they wouldn't be part of the same solution, which is why.
Right, we get 2b when we multiply by a now instead of b. Okay,
I understand.
And I feel like maybe we talked about this one previously because this is the one that was like out of order. Number 3 says like, is it a subspace? Really, you should answer question 4 before you do that one, which says, is it closed under multiplication? And so pick something in the set again. So let's do ax1 equals b. What happens if we multiply this by a constant and then we multiply it by a, right? So I'm taking something that's in the set, I'm multiplying it by a constant and checking to see if it's still in the set. Well, when you do that, you can move the constant out front. This becomes b, and so we get cb, not b. And so if c is not 1, well, this is also going to fail. So fails if c is not 1. And so since all 3 things failed, it's not a subspace, right? All you need is one of them to fail for it not to be a subspace, but all 3 of them failed. And so all 3 fail. And so that's why this is not a subspace.
Okay, I think I understand.
I'd like to give someone else or a chance to ask a question. Other thoughts, or you can ask a specific topic if you want to go over something. It doesn't have to be specific homework questions or anything. I'll remind you again too, like, don't forget that all the book questions, I posted solutions for all of those. So if you wanted to, you know, for example, if you're looking for another subspace question to try, you might look at the ones from the book because I posted all those solutions. Was someone going to say something?
I think I wrote down, I said I was going to ask, just to verify, you can check if something's one-to-one if there are no free variables. That's how you verify if a transformation is one-to-one. And you can verify a transformation is onto if there's a pivot in every row.
Correct.
Okay.
I should just mention too, I mean, based on the IMT, I mean, that's how we talked about it. That's how we explained like the way it's true. But I mean, you can check any of these things technically to check to see if they're one-to-one or onto. That's just the way, that's just what you said follows directly from the definition. But I mean, technically, if A is not row equivalent to the identity matrix, it's not one-to-one either, right? Or if it's not row equivalent to the identity matrix, it's not going to be onto. I guess this is only if it's square, though, now that you mention it. So forget what I just said, because linear transformations may not be square. So this is only for square matrices, and so erase your memory of what I just said. So what you said was absolutely true, though.
Okay. And also to verify, to find the inverse of a technically any matrix, but I guess in practical terms, ones that are larger than 2 by 2,
Yep.
You would put it in an augmented matrix with the identity matrix, and then do RREF, and the side that once was the identity matrix should turn into the inverse matrix.
Right.
Correct?
Yep, you put the matrix in with I, the identity matrix, just like you said. You row reduce. If A turns into I, then I, whatever I turned into, will be the inverse. If you get not I, then you're going to get not the inverse. Right? In other words, no inverse will exist. So you should row reduce. And, you know, if you remember, just like I did on the last test, I will have it row reduce for you. That's how that question worked. Remember on the test, I gave you one, and A did not turn into the identity matrix, which means it wasn't invertible.
Okay, I was just verifying that.
Yep. Anything else? Most people are being pretty quiet here. I hope that's just because you're confident, feeling good about this. I know you all can do this, especially with notes. I mean, geez, as you're going here, just start writing stuff down. You know, get the IMT on there, do a couple practice problems that were tricky. If something that we did today, you know, oh man, I should write that down, get that written down. There's really no reason why anyone shouldn't do really well in this, I don't think. So
I have a question about the notes for the exam.
Sure.
Can they be typed or all written?
You're welcome to type them, I guess. It's fine.
All right, thank you.
I guess one more question I could ask
before
I go. Just to verify one more thing. I know that in the coordinate chapter, a large part of it seemed to boil down to B time. So it's sort of basically sort of boiled down to an equation similar to AX equals B, except it seemed to be B X with, you know, that symbol that looks like the square brackets with B outside of it with X inside of it. You know, so B times that equals X, more or less.
So you're talking about like something like this.
Yes.
Right.
So that with a b in front of it, so that times b equals x in the same way that ax equals b.
Yeah, what is that formula? Let me pull it up real quick.
I know that in the actual coordinate web work, this is the way that we sort of solved most of the problems. I sort of think about it like this.
Yeah, so we had this formula. We had, you can represent vectors by taking their change of coordinate matrix and multiplying it by the coordinate mapping. Or you could do the inverse of the change of coordinates and multiply it by the coordinate mapping. I think this is what you're talking about. This is from section 4.4.
And P of B means the basis of a certain matrix, right? Or B of P, I guess. However you would say that.
Yeah, so this this is like a matrix with the basis as the columns. And then this is a column vector. And so this would be the inverse of that then. It would be the inverse of this matrix. And this is a specific vector. So what this is saying is you can get any specific vector by taking the basis for a space and applying the weights in the column vector in the coordinate matrix. That's like the definition of what a basis is. And what we had said was, well, one way to figure out what the coordinates you need are, which would be this equation, would be to take the inverse of this one and multiply it on the left by the one you're trying to find. So I don't remember what your question was, but this, I'm pretty sure it's this relationship that you're talking about, right? So do you want to maybe restate what you had said?
I was just trying to relate this formula with ax equals b, because I remember that a lot of the questions in 4.4 sort of boiled down to effectively finding x in this case, except x in this case was more or less just sort of the column vector thing with the square brackets. I apologize for not remember the name of that. Is that the coordinate weights, I think you said?
Yeah, the coordinate mapping, technically.
Right, coordinate mapping.
So, we had this relationship. If you have the equation ax equals b, you can multiply on the left by the inverse, right? These two things cancel, and then you get this. X is a inverse b. And so that's the same thing that's going on here. It's like this is this side, and this is this side. Because you've got like a matrix times a vector equals a column. That's this thing right here. And then this one is a column equals a matrix times a column. And that's what this one is, right? Column equals matrix times column. And so it's the same kind of multiplying inverse idea. It's just instead relating it to this basis thing. And don't get me wrong. The hardest part about this thing that's in 4.4, this upper line here, is the notation. Like, you're just trying to describe it and you're saying exactly it. Like, what is this, a P sub B thing, right? I mean, like, what does that even mean? Well, that's just the basis of the columns, right? And the square bracket X sub beta, I mean, that's just saying the coordinate mapping. It's like the weights that you're using for the basis elements. So I really think if there's any confusion about this, it's all about the notation. And it's kind of hard to sort of clarify notation, I don't know, without going back through the section. Could go back to the section.
I don't think we need to go back to this section. I think it's just a very small semantic ID here. Because I know that in one of the questions, I apologize to go back to the questions in the web work, but one of them said that the basis B consists of 0, -6, and -7, 5, and the relative and the coordinate weights. The one
Can
on
you tell me
B.
what you're looking at here? Homework set.
It's 4.4, problem 1.
Yep. All right.
And the way that I solved this one, in the end, the answer that I got was 2816. And the way that I solved this one was treating the x sub b similar to how you would treat an x if you were multiplying it by a, basically. And that seems
yeah, you want to use this equation right here, right? So you want x, you're given these two things. P sub b is this matrix. This is this right here, right? So you're just multiplying this matrix by this to get x.
Yes, correct. And in the next one, it gave us x, and it gave us b, and we had to find x sub b. And the way that you would solve that one, or at least the way that I solved that one, was just taking b and putting it in an augmented matrix with the x that was given to us, and then doing RREF and finding the solution that way.
But why does that work though? Shouldn't it be like the inverse of the? Yeah, so I don't understand why that worked.
That's the only thing that's a little bit confusing to me right now.
Because I just verified it and it worked.
All right. So are we okay with question number 1? Can I flip over to question number 2?
Yeah. Yep.
So question number 1 should have been kind of easy because all you had to do was do the left-hand side of that equation. Number 2 gives you different pieces of information. So number 2 says you're given the x and you're given the basis. So the P sub b would be just the matrix. These would be the columns of the matrix, right? And then it wants you to find the coordinate mapping. All right, so on the last problem, you're using this one because you're given these two things. Right? Now we're trying to find the coordinate mapping. And so you're given these two things. But you need to figure out what the inverse of this one is. All right, so we know that. Let me just do this problem the way that it's supposed to be done and then clarify your question. We know that this is true. Sorry, this should just be an x. Right? And so PB is this with the columns. 1, 3, 6, 0, 1, minus 3, 0, 0, 1. And so you would find the inverse and multiply it by x. And that's how you would get this thing here. Now, what did you say that you wanted to clarify why that works?
Yeah,
Not exactly.
Yeah, the way that I've been solving these problems is just by taking B, the matrix B, and putting it in an augmented matrix with X, and that has always given me X sub B.
Yeah, that's fine too, right? Yeah, sure. So this, you can do X equals C1 times this, C2 times this, C3 times this. And so, yes, that would be putting X in an augmented matrix and solving this equation.
Okay, so yeah, just to verify, b times x sub b equals x in the same way that a x equals b.
Yeah, that actually makes sense now that I think about it.
Yeah,
Because you're trying to find like. Yeah.
You're directly doing it rather than multiplying by the inverse.
okay.
Right? It's like you can solve ax equals b by putting a and b into a matrix and row reducing, or you can multiply by the inverse, and those are both two different ways to solve the same problem.
Yep.
One sort of directly doing it by row reduction, and one's doing it by multiplying on the left by the inverse.
Okay. Yeah, I think that makes sense to me now. I just wanted to verify that I wasn't like doing some weird thing that wouldn't work in every case.
Nope. Yeah, that's fine. And I think in that chapter we kind of mostly did it the direct way, and then it was like at the end that I was like, oh hey, or notice how this does this inverse thing that we also saw, and I think. And that's the confusing notation thing too. It gets very confusing notation wise, and maybe that's what just adds like another layer of confusion to the whole thing. But anyway, it sounds like you two are at least thinking about that correctly. Can I clarify that for anyone else? Clarify that further. All right, what else can I do for you? Anything at all?
The final is next Tuesday, right?
The final's tomorrow, man. Tomorrow afternoon.
Okay. I thought it was next Tuesday. All right.
I honestly can't believe you just said that. Yeah, I've said I've been telling you it's tomorrow for the last probably 6 weeks.
All right.
I'm a little bit worried now. Everyone hears me, right? I've said that about 5 times today already too.
Yeah, tomorrow 2:30 to
tomorrow
4:30.
from 2:30 to 4:30. It's been on the announcements every single day for the last at least month.
We have a final.
I thought it was next Tuesday, but all right.
Can we go over the determinant of a 3x3?
Sure.
Wait, this is news to me. I didn't know we had a final today or tomorrow.
Oh boy. I'm gonna hope that was a joke.
It was.
So I can read the entire book to you real quick. Yeah, absolutely. Just trying to pull out those determinant notes here. Looks like I've misplaced them. Oh, here we go. So determinant of 2 by 2 is real easy. You just do AD minus BC. But when you're doing a 3 by 3 or larger, just going to kind of run through the notes here. What we do is we expand down any row or any column. And so we pick a row or a column that's got zeros in it. And there'll always be a row or column, especially on a test. I'm going to put one that has like a bunch of zeros in it and hope that you know how to choose the right row. And we pick the right row or column and we alternate the signs, right? So we here's like a general matrix that we might have. We alternate plus and minuses across the rows and the columns. And then we pick the row or the column that's got the most zeros. We go down that row or column, and then this tells us how to alternate the signs that we're using. So like, for example, on this one here that we did, I chose the third column to do because it had a 0 in it. We could have also chose the first row or the first column or the second row would have been fine because they all have a 0. I just happen to choose the third one, which is nice, right? And so what you do is you pull out one of the entries you follow that plus or minus scheme that we had, right? So if we were in the third column, we'd be starting with a plus, and then the second one would be a minus, and the third would be a plus, right? And so that's why when we were going down here, we had plus, minus, plus. And we pull those numbers out. So that first number was the number 1, the second number is the number 0, and the third number is the number 1. And what we do when we pull the number out is we delete the row and the column that number is from, and then we do the determinant of that submatrix. So like when I pulled the first 1 out, I delete the first row and the third column, and then you're left with that matrix that's being shown between my pens, which is 5 minus 3, 2, 3, and that's exactly what we'd multiplied by, right? And then when you pull the 0 out, you'd be left with the 0, 4, 2, 3, which is what that second one was, right? And then when you pulled the third one out, you'd be left with just the upper left-hand corner here, which is 0, 4, 5, 3, which is what we did there. But notice that these are all determinants, right? So I'm doing straight lines, so we need to do determinants of those things still. And so then you do the determinant of that, doing AD minus BC, and you do the determinant of that one, doing AD minus BC, right? So like this negative 20 was 0 times 3 minus 4 times 5, right? That's how we got minus 20, for example. So that was just sort of like a quick rundown of the general process. I don't know if that's the kind of thing you're looking for, if you wanted to like look at a specific one, like from scratch, or if you just want a sort of a reminder about sort of the difference there.
What do you think like the maximum size of like the matrix you'd give us would be?
3
Like,
by 3.
okay, because like I'm worried if it was like super big, I wouldn't be able to fit it all on like the page breaks.
I have no interest in looking at something bigger than a 3 by 3.
Okay, cool.
Thank you. Thank you very much.
No, thank you. I mean, you know, once you get bigger than 3 by 3, it's the same thing. It's just, like you said, more steps. And so it's like, and why belabor the point? I wouldn't put more than the 3 by 3. And even the 3 by 3s I'd put would probably have a bunch of zeros. So I don't remember who asked that question, but is that sufficient, or did you want to look at an actual example?
Can we look at one? Can we look at one?
Sure. Let me find one quick here. So I'm going to open up the homework 3.1, and I think there's a 3 by 3 in here somewhere. Here's a nice one. So this is WebWork 3.1, number 3. The matrix is this. All right, and so when we're thinking about the plus minus thing, just to be clear here, it's like this is the kind of form we're following. And there's 2 zeros in the first column, and there's 2 zeros in the second row. And so either one of those would be a fine thing to choose. I'm going to choose the second row just because it also has a 1 in there. Doesn't really matter, but so what we do is we pull these entries out, but we're going to follow this plus or minus scheme, right? And so we're going to have like minus 0. I'm going to write it out as minus 0, even though it doesn't really matter. And then we'll have plus 0. And then we'll have minus 1. Okay? And then when we pull each one of those entries out, we delete that row in that column. So I pulled that 0 out, and so I'm going to delete the first row and the second column, right? And so I'd be left with those 2 and those 2. And so I'm going to multiply that by the determinant of that submatrix. It's going to go away because you're multiplying by 0, but hopefully this helps you kind of see the idea, right? Like if this was a test, don't even bother doing that because it's going to go away. But I'm hoping this just reminds you of how this works, right? When I pull this 0 out, right, you delete this column and that row, and so it would be those 2 and those 2. And so it would be this. Again, those 2 are just going to go away because you're multiplying by 0 anyway. So it's the last one that matters. When I pulled that 1 out, you delete the third column, second row, and you'd be left with that. This is the determinant, by the way. I should have said the determinant of A equals this. Does that seem okay so far?
Yep.
And so again, both these go away because you're multiplying by 0. This just turns into a +1, and so it's really just going to be 1 times this determinant. And it's a 2 by 2, and so you can do AD minus BC. So it's going to be 5 times -1 minus -2 times 0. And so you get 5 times -1, which is -5. And that was the answer of this one. And the second part was, does it have an inverse? Well, we know that part of the invertible matrix theorem says if the determinant is 0, it's non-invertible. And so determinant is not equal to 0, and so A is invertible. It's a very common sort of sub-question that goes along with these ones.
I wrote this wrong. It's the opposite. Let me just use Kramers for this, since it's easier way to get this done. I can just do it like this, this, this. All right, I should be good.
Wonderful. Any other questions right now, folks? Okay, I will post this video in case you want to go back and look at this stuff again. I'll also scan up these pages. I don't know if they're that helpful, but I will scan them up and post them on Blackboard as well. Please feel free to reach out for other questions, but I'll say one more time that the final exam is tomorrow afternoon at 2:30. Please try to be there. Please prepare with a nice cheat sheet to bring in, and we'll have a nice strong finish to the course. Don't forget, tomorrow is the last day to declare pass-fail too. And I'm not going to grade the final by the time you need to declare that. So you need to decide how you feel about, or I'm sorry, not tomorrow. I think Wednesday is the last day to do that. So you can take the final and still have time to declare, but you're not going to be able to see your final grade before you need to declare. You kind of need to feel out the course, see how your homework average is, and make a decision. I'm happy to consult with you about that if you're interested.
I apologize again for not sending questions beforehand. I
apologize for, I know I've been like jumping down your throat about it. It's a little bit frustrating.
I understand. This can't possibly be easy for you. I probably should have.
It's okay. It's not easy for any of us, and it just helps. I feel like I'm better able to help you if you just send those ahead of time, so I can think about the intricacies. I can print them out, all that kind of stuff. Anyway, it's a moot point now. Not a big deal. I don't mean to yell at you, but anyway. Thank you all. I really appreciate you hanging with me during this remote time. Again, it wasn't easy for any of us.